Going over the quiz. Going over the quiz. So for number one, the 5 over -1 to the 3n, and n is supposed to be equal to 3. So what you're supposed to do with this is say that you have a -1 to the 3 multiplied by 3. So that's the 9th power. And hopefully you can see right through to that. If you take -1 and multiply it 9 times, that's an odd number, so it should come out as negative. So that ends up being a -1, but then you should rewrite that as -5. That's how that should look. Check your work on that one and make a correction if you need to. A counterexample would be just a number that doesn't work in there. And I think you can pick almost anything other than 0 or 1 for both of them. So any value other than 0 and 1 for A and for B. And a nice way to have written that would have been something like, if some of you did this, you said, well, A is equal to 2, B is equal to 3, or something like that. That works, that's great. Or you could actually substitute it in and say that 2 squared times 3 equal to 3 squared times 2, and then just say not equal to. Some of you did that too. 2 equivalent algebraic expressions describing the total number of fingers and toes. So, barring accidents in shop, you should have 10 of each. So, I mean, there's lots of ways to write it. You could say, well, I got 10n plus 10n. You could write 20n. Some of you wrote 2 times 10n. There's some other versions that worked as well, but those are a couple. Yeah?
Oh,
2 sets of 10, yeah. Or you could say 4 sets of 5, 4 times 5n, or 4n times 5, This is probably better than that. I'd take it. But. Okay, then for 4a, you can't just assume because you think you see a pattern starting that it continues. You have to check the third term. And for that one, just the table itself, for 0 you get 4 and 4, for 1 you get 8 and 8, for 2 you get 14 and 12. And right there it shows that the expressions are not equivalent to one another. This one up here was n squared plus 3n plus 4. And this was 4n plus 4. And here you got 22 and 16. So they are not equivalent because if n is equal to, this is what, 0, 1, 2, if n is equal to 2 or n is equal to 3, the equations don't check. Then number 5, if you substitute 3 in for n, you'd have 6 times 3 plus 3 divided by 3. If you follow the order of operations for that, you get 19. For letter B, if you had 6 times 3 plus 3, and all of that was divided by 3, then you would come up with, I think, 7. And then for letter C, if you took 6 times 3 plus 3 divided by 3, then the order of operations you get 12. And not until you get to D, where it's 6 times 3 plus 3, divided by 3, then you get 24. So letter D is your choice. Number 6 is a mess. I don't even want to talk about it. I should have crossed that out for you, sorry. It's just I don't know who wrote that one, not me. Number 7, both commutative and associative. Because the 5 and 7 have parentheses around them in the second half of this. So when it's written, this has parentheses here first, so you have to do that first, and then multiply by 7. And then what they did is they changed the order of the 5 and the x squared. They flipped them. And then they said, now you got to do the 5 and the 7 together. So it's both commutative and associative. If you named one of them, that was okay for 1.5 out of the 2 points. The terms, number of terms. Terms are separated by addition or subtraction. We said that a number of times. Sometimes I don't write down things that I want you to internalize. But the number of terms is, in this case, 3. That's a term. This is a term. And a 4 is a term. Like, when we combine like terms. We bring things together to a point like this, and then we have separate terms. These are all unlike terms. They're different from one another. Any questions on that? Keep it, because it might help you in preparing for the test, which you're going to have next week. We're going fast. We're on lesson 6 already. You will find that this class moves really, really quickly because we meet 5 days a week. So, you know, yeah, it's 4 days this week, 4 days next week, but your other classes are only 3 days, right? So this thing rolls. It doesn't slow down. A word to the wise, don't let it get ahead of you. It's nearly impossible to catch up. Very, very challenging. If you're finding you're struggling and getting behind, Joan is available to help you guys as well as me. You just have to say something, and she'll work after school. She'll work during the day if you have a free period at all. I'll work after school. My only free period is 4th period, and frankly, during that time, I'm not free to be able to help students, other than just a quick question here and there. Most of you have got something. You got help going, right? And so for freshmen, it's tough because algebra flies, and you oftentimes don't have homework help time, and you know your other classes are cruising right along too. So, but you get out at 2:15, and we're here. All right. So then your work on graphing calculator. You want to ask any questions about it? What, you must have gotten stuck with something. Well, you guys have it. What again? Why not? Oh, yeah, it's hard, doesn't it? So, look hard, look fast, ask questions now, and hopefully do it. Did you get through? No. I gotta see it though, make sure you bring it in. You and I went back and forth a little bit, but you still got hung up on it. So we're 0 for 5. I'll say this. I don't wait. You know, it's like none of you got it done, right? So, you know, if I was a really nice person, I'd say, okay, well, let's just spend the rest of the hour working on it to make sure that we're all done with this lesson and we're caught up and up to speed. But I can't do that because I have a certain amount of material I have to get through with you guys by the end of the year. And one of two things happen. We either keep up or we don't. You know, I know it makes me sound like it, you know what, but that's just the way it is. We have to get through this. I can't at the end of the year say, oh yeah, you completed Algebra I. We have 2 paces. If this is too fast for you, you can be in the other pace. But then you're also looking at taking 2 years to get through 1 year of freshman number. And you guys, you're here because you shouldn't be in that situation. You have the ability to easily do this. But you can't let yourself get behind. You gotta take responsibility. So I'm moving forward. Get that done, get it into me. If you want credit for it, show it to me no later than tomorrow. For half credit tomorrow. If you want help with it, come in after school. I know the graphing calculator stuff can be confusing. It's a lot of keystrokes to remember and keep straight. But it's a tool that I want you to be able to use. It's a tool that I'm going to teach you to use more and more as the year goes on. Because in the end, it makes your work less. So then, moving on. Lesson 1-6, absolute value. what do you guys remember about absolute value? We've done it for the last couple of years. So you're going back, you're reading what it says there. Do you remember the symbol that we use for absolute value? So we'll take a look at this. What if I had -5? We had 2 bars like that. So that gets rid of the absolute value of -5. That's how we would read it. So absolute value, this is the definition. It's the distance that a number is from 0 on a number line. So if we look at -5, if this is 0, here's -5, that distance is going to be 5 units. Because when we measure distance, we don't talk about direction. I'm sorry, we don't talk about positive and negative. We may talk about direction. We might say it's up 5 or down 5 or north 5 or south 5. But we don't ever say it's -5. So an absolute value is always going to come out as a positive number. And the absolute value is a grouping symbol, so it's like parentheses. So if there's something on the inside, for example, if we have something such as subtraction, 5 minus 3, and that's on the inside of the absolute value symbol, we have to do this work first, and then we get a value coming out. So in this case here, the absolute value of 2 is still positive 2, because 2 is going to be a distance from 0 of 2 units. So we think of everything on a number line, and that's what absolute value is going to be. Now, the number line doesn't have to be horizontal, it could be vertical. So, for example, in an ocean, at 0, what is that commonly referred to as? What is it? So if you go out here on the ocean, you're at an elevation of 0. What is that called? Sea level. Yeah, I can't hear you guys real well. Mast, fans, so that's sea level. But if you were up here, like at that kind of an elevation, then the distance is going to be 14,110. So the absolute value is going to be that number, 14,110. But if you're down here, let's say you go down into a location which is below sea level and you're 2,000 feet below the surface of the ocean, the absolute value is that distance, which is still going to be a positive 2,000. It's just in a negative direction, or it's in a downward direction. So the absolute value of -2,000 comes out as 2,000. That's the distance that it is away. So they have a little story, not a story, and some facts about a place in New Mexico at the beginning here. And White City is in New Mexico. It's near the Guadalupe Mountains, near Carlsbad Caverns, which are huge underground caves down in southern New Mexico. And these caves go down below the surface of the earth a certain distance. But they also begin at an elevation above sea level. So rather than just working with numbers like we did in middle school, like such, And there's a little bit of arithmetic that's going to go into solving some of these problems that we're working with. And some of the numbers on the top of page 43 are going to be relevant. Guadalupe Peak is 8,749 feet above sea level. So I'm going to erase this and scribble a little bit out there. Draw a vertical number line with this. So if we had 0, and then we had Guadalupe Peak, which is 8749. That's Guadalupe Peak. And then we have Carlsbad Caverns at 4,400 feet. So there's the Carlsbad Caverns. And then we have King's Palace, which is in the Carlsbad Cavern. So if you go into the cavern and then you go down to an elevation above sea level of 3,500, you're at King's Palace, which is a huge, huge room in Carlsbad. Have any of you ever been there? Okay. So here we are. We're at sea level. The entrance is 4,400 feet. And then you go down into this cavern. How many feet would you go down from the entrance to King's Palace? 900 feet. So that's pretty significant. It's rather deep. Okay, so let's keep those numbers in mind, because you're going to be able to use those in a little bit. Got your graphing calculator? So a graphing calculator can be used with graphing absolute values. Recognizing what the graph of absolute value looks like is important. But it's not a key. You gotta go in, you gotta go into your calculator and find absolute value, which is abbreviated ABS. I think, yeah, I put that on the Google Doc. To get to the absolute value, you use the math button, and then NUM for number. So if, for example, if we wanted to just graph y is equal to the absolute value of x, we wanted to graph that, we would go into our y equals. So why don't you do that? Go into y equals, make sure you have everything cleared off of y sub 1, y sub 2, etc. And all we have to do is enter the absolute value of x. So you start by going to the math key, which is right underneath the green alpha. So go to math, and then it pops up, it says math number, it says that's complex, probability, and fraction. Those are all different functions. So if you scroll over to number using the arrow, the very top one is ABS. And if you just hit enter, that puts the absolute value bars into your y equals. And then you just type in your variable x. What did you get? Yeah. So use your graph now. Put it in the standard window. I don't know what your windows look like right now. You know, you just get your variable that you want. X. And graph in the standard window. What are you doing over here? So the graph of y equals the absolute value of x looks that one thing. So it works like this. If you came out here to 5, the absolute value of 5 is going to be an output y of 5. If you came back here to negative 5, the absolute value of negative 5 is also going to be 5. So there are no absolute values which are negative. Go back to y equals though. And go down to y sub 2. So go to your second function. And now what I'd like you to do is I'd like you to enter a negative. And then go and find, using math and number, the absolute value of x. So now graph it like this.
It's the same thing, except negative.
So now you have a negative absolute value of x. What's it look like?
It's very sharp here.
But it's going to be opening.
Oh, I did not get that.
You didn't get this? Let's see what you have.
I'm gonna find out what I got. Oh, it's the exact opposite.
Well, you did that, negative 39.
Oh,
I thought we didn't
that
like
was
the
not.
number.
Oh, no, just a negative, which ends up being a negative 1. So yours looks great. That looks great. So if you did a negative 39, yeah, it's going to be really, really sharp. Because you're taking every single answer and multiplying it by negative 39. So it's just going to be fun.
I did try.
How are you doing? You with it?
Yeah.
Okay. Yeah, so if you do this, then any number that you find the absolute value of, this is the grouping symbol, then a negative 1 is applied to that, or multiplied by it. So if I had, in this case here, y is equal to a negative absolute value of 5, you take the absolute value of 5, which is positive 5, and then the negative gets put in front of it. So that's why your graph drops off like so. All right, a little bit of a sidebar. Now let's go back to where we are at. Dun, 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 dun. I want to make sure I'm giving you what you need for this. I know it's like a really short introduction. Yeah, let's work on it. You got time. Probably best to work on your assignment and then answer questions as we go.